In this video, I will show you a general rule that you can follow in order to integrate a function which is of the type 1 over x to the power a plus x to the power b. The general rule that I like to follow, especially when a and b are in terms of fraction, is what you do is you take LCM of x to the power a and x to the power b and put that LCM is equal to u, and the integral will solve automatically. Let's see how that happens. In this case, for x to the power half and x to the power 1 by 3, the LCM of those two is x to the power 1 by 6. So what I'll do is I'll put x to the power 1 by 6 as u, and this integral will literally solve automatically. Now what you do is just take the sixth power on both the sides, and then let's aim to convert this integral from the x world to the u world. So if you take sixth power on both the sides, this will become x is equal to u to the power 6. Now let's differentiate both the sides with respect to x. So you get dx is equal to 6u to the power 5 du using the basic differentiation result. Now let's try to convert that integral from the x world to the u world, and let's see how that will look. So if that integral, let's say, was I, so now that I will become integral of 1 over, instead of x, just write u to the power 6. Okay, so you have u to the power 6 to the power 1 by 2 plus u to the power 6 to the power 1 by 3. Instead of dx, just write 6 u to the power 5 du. Now what you can do is you can use the law of exponents here and just multiply these terms. So that will give you integral of 1 over, so 6 times half is nothing but u to the power 3 plus 6 times 1 by 3 is nothing but u to the power 2, and in the numerator you already have 6 u to the power 5 du. Now that 6 is constant, can be taken out of the integral, so you have 6 integral of u to the power 5 divided by, from the denominator just factor out u square, so u square, so you'll be left with u plus 1, and you just have du over here, and this u square with u to the power 5 will get cancelled, and you will get u cube in the numerator. Now it is actually very easy to integrate at that point. I'll show you how. So we have u cube over u plus 1 du. I hope that makes sense. Now what you do actually is, let's do some adjustments in the numerator. What do I mean by that is you add 1 and subtract 1, just like you have in the denominator. Try to bring that structure in the numerator. So what you will have is 6 times integral of u cube plus 1 minus 1 divide by u plus 1 and with respect to u. Why do I do that is because this 1 can be thought of as 1 cube, and then I can apply a cube plus b cube formula over there. We know that a cube plus b cube is nothing but a plus b, a square minus ab plus b square. Okay, so if I use that result over there, I can cancel something which is extremely important. So I have 6 integral of, I can write this as, using this result, u plus 1 u square minus u plus 1. I'm literally using this result right here. Okay, minus 1 divide by u plus 1 with respect to u. Now what you do is just split that denominator in both of those terms. Okay, and you can cancel then u plus 1 after splitting. So you will have 6 integral of u plus 1 times u square minus u plus 1 divide by u plus 1 minus 1 over u plus 1. So we did a split of that denominator in both of those terms. Now you can cancel that u plus 1. So now it's a very easy integral, because basically you can just split that integral in all of those terms at this point. So you have 6, let's put the bracket. So give integral to literally all the terms. So give that integral to u square. So you have integral of u square du minus integral of u du. Give that integral to u plus integral of 1 du. And in the end, give that integral to 1 over u plus 1. So minus integral of 1 over u plus 1. du. I hope that makes sense. Now with the basic formulas of integral, so you have 6, let's put a bracket. Integral of u square we know is u cube by 3 minus integral of u is u square by 2 plus integral of 1 is nothing but u minus integral of 1 over u plus 1 is ln u plus 1. Let's add the constant of integration c, and this is your final result in the u world. We'll have to convert it back to the x world. So if you remember, what was our u initially was x to the power 1 by 6. So let's resubstitute that and let's see what do we get, which is actually our final result. Also multiply this 6 inside. So we have 6 x to the power 1 by 6 cube divided by 3 minus, multiply that 6 with this, x to the power 1 by 6 square divided by 2 plus 6 times x to the power 1 by 6 minus 6 times ln u. So I have 6 times ln, instead of u just write x to the power 1 by 6 plus 1 plus the constant of integration c. We can clean this up a little bit if we want. So 3 times 2 is 6, 2 times 3 is 6, and we can multiply these using law of exponents. So we have 2 x to the power half minus 3 x to the power, so 2 divided by 6 is 1 by 3 plus 6 x to the power 1 by 6 minus 6 ln x to the power 1 by 6 plus 1 plus constant of integration c, and this is nothing but the final result of the integral that we are looking to solve. How easy was that integral when you know that general rule that whenever you see the integral of the type 1 over x to the power a plus x to the power b, where a and b are fractions, just take the LCM of those two terms and put that is equal to u and just keep simplifying. You have your final result right there. If you understand this concept, can I request you to like this video and subscribe to this channel, because I do post math and calculus content every single day and I don't want you to miss it. So I'll see you tomorrow.